There are two basic types of air filter. There are filters for solids, and there are filters for gaseous particles. Both types of filter have the same objective, and that is to reduce the concentration of pollutants. Let's focus on gaseous particles, which can be filtered out by means of adsorption, and not to be confused with absorption with a B. Wikipedia defines adsorption as the adhesion of atoms, ions, or molecules from a gas, liquid, or dissolved solid to a surface. Adsorption is brought about by London dispersion forces, or van der Waals forces, which act between the molecules. These forces are like the force of gravity acting between planets in the solar system. Because of adsorption, the activated carbon in air filters can remove VOCs and other gaseous pollutants from the air. Different types of carbon may be used, depending on the field of application. There are 4 ways of capturing particles. The filter class, the particle size, and the filter construction jointly determine the magnitude of the effects. First is the sieve effect, the most common used way in air filters because the principle is so simple. A particle is larger than the gap between the media fibers, and therefore it gets trapped. Next is the inertial mass effect, which works with particles that have substantial mass. The particle arrives at high velocity, but due to its mass, it loses control and collides with the media fiber instead of just going with the flow. Imagine speeding through a winding road at full speed, and you'll get the idea. Third is the interception effect. We learned earlier that particles exert forces of attraction on one another, and that's the principle at play here. Larger media fibers attract small dust particles. Once the small dust particles have been intercepted, they get stuck between the media fibers. Finally, we have the diffusion effect. Particularly small particles often have an irregular path, referred to as a Brownian motion. This path may digress from that of the airflow, hence increasing the chances of the particle colliding with the media fibers.